we can think about this is a convolutional neural nets, particularly for computer vision tasks. So what happens is that you don't have like a very general neural network structure, but rather say I can make use of this sparse connectivity. In other words, I not connect to all the nodes to all the nodes. I only make sure that they are locally connected. So what do I mean locally connected? Is that, for example, for this tree are connected to reach the average and become my next layer value. And also I shift one sort of one nodes. I can looking at this, and create a. I can also shift a bit and looking at this tree, and create a sort of a next layer. So in other words, think about this is really nothing about I would apply the filter with same for example with the same sort of a parameter. You could obviously apply different filters, therefore with different sort of with a different parameter. So in this 2D case, you can think about this. That I have this filter, right? And then basically what I can do is that in this filter, I have different weight. And then I would weighted average of every value right here, and then create value, create a value, and I put it into the next layer. Then apply this sort of filter again, shift one, let's say pixel, and we'll do the calculation again and become this. Therefore, when I finish off this filtering, move over all the pixels, I got this value of this next layer. So this is a convolutional neural nets. The thing about this is that you can apply multiple filters with different sort of weights, therefore can create, different sort of output, and then you can, and each of them can have the their filtered again, put it to the next layer. So this is the original convolutional neural nets idea, and being used for to recognize zip code, being very successful. And at the time, is obviously is quite complex model, but as in terms of the most of these techniques like subsampling and apply the convolution layer, subsampling again, being also you can see that in our current sort of a modern convolutional neural nets as well. But the idea is quite quite similar. So yeah, this is basically to try to explain that you can actually have a different kernel with different weights, therefore can create a different feature map. And yeah, you can also using this so-called pooling techniques, is that you want to have this dimension reduction, right? So instead of basically making use of all these four, I pick out one has a maximum, and therefore allow us to really to getting the most responsive nodes and put it to the next layer. Obviously, you lose some other information. So it's sort of that is a balance between computation and also efficiency. And so this is sort of result. And then these modern sort of convolutional neural have been heavily used not only on the image, but in fact on the natural language processing program as well. So ImageNet has been become kind of a standard for all these computer vision tasks and also classification tasks. And as I said, that in the very beginning, sort of back in like 2015, they already passed this human better than human in terms of recognize the objects in the image. And this is what happens now, right? In terms of top one accuracy is already more than 90%. And they also have some technical in history. I'm not sure whether people use it now, but they have in terms to make it more generalized, not overfit to tend to sort of a drop out, to randomly drop off some of the note. So this is one of these some of this popular neural network structure. So this is like a 22 layer that I mentioned in this lead table. And the interesting developed after this convolutional neural nets is this called residual nets, which really boosts this layer into like 1,000 layers. If you have really computing power, you can certainly do that. So the idea, in fact, is not unique, because in the past we also people talking about so-called highway connection. So in order to train is quite a deep network. One of the problems is this: when you propagate an error, probably can't. If you have 1,000 layers, it's very difficult for you to propagate to like early layers. So what you can do is that so-called using this path links. When you have a path links, it's like a kind of residual. Is that I want to pass this, and also anything in between is become sort of a difference between this. It's become the f function. So if you stack all together, you can think about this as that when you have this gradient error, you can actually bypass this back to the end. So they will be make this training like a very deep possible. Therefore, people can observe, the performance, significant performance gain when if you're able to train like even 1,000 layer network. So you can actually using the convolutional neural nets for text classification as well.